Hello everyone, welcome to today's module, and today we are going to talk about bathymetric data processing as part of the H6 module of IHOS5. So, when we're talking about bathymetric data processing, the first thing that comes to mind is actually data cleaning. And how do we actually clean our data? So the first thing that we need to know, and I think you already know this, is actually to identify outliers, okay? So what are outliers? So when we've got, for example, these green lines and this magenta, I guess, yeah? These magenta lines are survey lines. And this magenta from south to the north is actually this, okay? So that's the cross profile of the magenta, and this is from single beam echo sounder. So the outliers are actually the data that is, that doesn't make any sense if you have already seen, oh, okay, this is how the bathymetry looks like. This is how the morphology underwater looks like. And if there are some data that is not actually there, so those are outliers. And you can see these are actually outliers as well. So how do we actually deal with large error values or the so-called outliers? So the first thing you need to do is just like this. So you do it in visual form. So you plot them basically. So for example, only this line, and you do it line by line. So you actually have the grasp of like, okay, this is how the morphology looks like. And then if there's something wrong in that, you just take it out. So that's the basic thing that you need to know. You need to eliminate it rather than correcting them. You don't want to correct them. You don't want to incorporate them back to your data set. You just want to delete them altogether. So as I told you before, this is a single beam data set before you remove the outliers, and this is after you remove the outliers. So you can see here, there is no more outliers, and you've got your best approach of seabed morphology. And how about multi-beam dataset? So in multi-beam dataset, some large error values are not necessarily outliers. They might be systematic because, as you can see, in multi-beam bathymetry, you've got swath and then you've got your attitude of the vessel. So sometimes it's not necessarily because it's wrong, but it might be because of the movement of the vessel itself. So for example, at the top right in here, I hope you can see this, although some of it are covered by my face. So we're going to focus on this area. And if we zoom in, we see some spots that doesn't make any sense probably. So what are these? And actually, if we focus on them one by one, they actually have several hypotheses of where they are. So this is one of the algorithm that is done by Keras, for example, and I think every single bathymetric processing software has their own way of noticing which one, which one is right or which one is wrong. But basically, in this hypothesis, you've got several data points in one horizontal position. So those are called the hypothetic depths. And how do we deal with these hypothetic depths? How do we actually choose them? Will be explained in the next segment, where we are going to talk about systematic errors.